Hello everyone. In this session, we are going to talk about the crystallization. In organic chemistry lab, crystallization is still the most important technique for purification of organic compounds. So, uh, in, we are going to show you that we have a different type of the solids. They are in the single crystal form. Basically, they are completely in one direction, and they have the one order, like a sugar rock, that is completely crystalline. Or we have the polycrystalline, like a metal. um, Iron slab is a polycrystalline solid, or amorphous kind of materials like polymers. They are amorphous. We don't find any um, order or direction in unit cells of this type of material. So basically, the success of uh, crystallization relies upon the assumption that compounds are soluble in hot solvents, and they are more soluble in hot solvent than in cold solvent, which is basically true, that we can uh, add the temperature and increase the solubility of compound in our solvent. Um, you, we need to define polarity. We need to know that compounds are soluble based on their polarity in solvent. As you know, water is a polar solvent. Why? Because between hydrogen and oxygen is a dipole moment, which is very strong because of the hydrogen bonding. And for that, uh, water is a polar solvent. And we have a dielectric constant epsilon that we can measure for uh, solvent. Water has a high dielectric constant. Polar compound is more soluble in polar solvent, and non-polar compound is more soluble in a non-polar solvent. Here we have three different type of solvent: highly polar, moderate polar, and non-polar. Water, as I mentioned, has a strong dipole moment between oxygen and hydrogen. That's why it has a high number of dielectric constant, 80. It can dissolve uh, polar compounds like benzoic acid and carbohydrates like sugar. Uh, other other high polar solvents are uh, dimethyl sulfoxide. DMSO is highly polar compound solvent. Uh, it can dissolve like uh, PbI2. It can dissolve PbCl2, PbBr2, that we can dissolve them with water. Uh, so the second type of solvent are moderately more polar, like dichloromethane, because between chloride and hydrogen, uh, the polar moment is not as strong as polar moment between oxygen and hydrogen, because we don't have a hydrogen um, bonding here between chloride and hydrogen. So the solvent is moderate polar. The dipole moment is weaker here than dipole moment between oxygen and hydrogen. It can dissolve moderately polar materials like caffeine and nicotine. And at the end, we have a hexane or toluene. They are nonpolar solvent. They can dissolve nonpolar compounds like wax, oil, uh, and uh, those materials are not soluble in polar materials. So how the crystallization can proceed? You need to first know that the impurity should be much less soluble in solvent of the substance that we aim to purify in order to be removed by filtration, or alternatively that impurity should be much uh, soluble in the solvent, uh, so at the end of the procedure it stays in this solution. So as I mentioned before, selecting the right solvent is very important at this experiment. For our impurity, we need to select a solvent that either impurity is much less soluble or much more soluble in the solvent. It cannot be soluble in the solvent like the substance that we want to crystallize. So if it has a solubility like the main substance, we cannot purify the compound. As I mentioned, temperature is very important here. First of all, we use the hot solvent. We dissolve the impure compound. We have the impure compound in the hot solution, and then we let the hot solution to be get to room temperature. When it get to the room temperature, because the impurity are still soluble in the in solvent, they stay soluble. But the main compound that we want to crystallize, they precipitate as a crystallized form in the at the bottom of the Erlenmeyer flask, so we can separate with the use of filtration, and still the impurities stay in solution, so we have the solid on top of the filtration paper. So how we proceed in the lab? We are gonna use two beakers. In one beaker one, we are gonna use 0.5 gram impure benzoic acid and 20 milliliter water, and the other beaker two, we are gonna use only hot water, 15 to 20 milliliter hot water. After we dissolve the beaker one, we are gonna filter, and we filter the beaker one solution with the paper, and we are gonna have the beaker two to wash any matters that stays on top of the filter. So inside the Erlenmeyer flask, we have the solution of impure benzoic acid in this step, and in the second step we are gonna let the flask to be cooled down to get to the room temperature. If we didn't see any kind of precipitation, we should use that we should put that Erlenmeyer flask inside the mixture of ice and water to cool down the whole solution lower than room temperature. When we have the at that condition, low, like around 5 degree or 6 degree, you will see some precipitation in the form of the crystallize of the compound or crystallized benzoic acid. Uh, so for separation, we are going to use the filter flask that is connected to the vacuum, and we are going to use the butcher funnel. We are going to then connect the flask to the vacuum pump, and then we need to fix the whole system with the clamp. We are going to use the rubber to seal the flask, and then we are going to use the paper filter. We can soak the paper filter in advance in the hot water. So we are gonna pour the solution on top of the filter, and turn on the vacuum pump. We wait until the whole solution separated the from the crystallized form of uh, benzoic acid. In the inside the filter flask, we have the solvent and impurities. On top of the paper filter, we have benzoic acid that they are pure in the crystallized form. So at the end of the experiment, we are gonna estimate the recovery percentage. How we do that? We are gonna weight the final crystallized of the benzoic acid, and we divided that weight to initial impure materials that we had. So we are gonna get a recovery percentage which is lower than 100. At the end of the experiment, we have the benzoic acid filter paper as a solid waste. We have the broken glass as a, if there is a broken glass, as a glass waste, and all the accused that they are contaminated with the benzoic acid are the aqueous waste. And we need to clean the balancing room area. Thank you for your consideration and listening to this video.